All right, let's verify some more identities. Notice we've got some different stuff going on here. Really some. Okay, so I'm going to start with the left-hand side. Rewrite it like I'm supposed to. And then the step after this, I'm going to use the sum difference formula for sine. And then I'm going to use the sum difference formula for cosine. So for sine, remember sine is the alternating one. So I do sine of the first angle, which is x, times cosine of the second angle, which is pi over 6. Keep the operation, plus cosine of the first angle, which is x, and then sine of the second angle, which is pi over 6. So that's just sine of x plus pi over 6, minus, okay, I'm going to put some brackets here so it's clear we're subtracting all of this. Now cosine is the one that doesn't alternate, but the operation changes. So cosine is cosine of the first angle, cosine of the second angle, and then again operation changes to minus, and then sine of the first angle times the sine of the second angle. Okay, so again the explanation, and again myself enough room, but that's the sum difference formulas. Okay, now the next line I want to distribute. So I've got sine of x times the cosine of pi over 6, we'll handle that in a minute, plus the cosine of x times the sine of pi over 6, we'll also handle that, minus the cosine of x times the cosine of pi over 3, okay, and then plus, because this negative distributes inside, and then that's sine of x, sine of pi over 3. So explanation there is just the distributive property, or you distribute. All right, now I want to evaluate. I want to evaluate pi over 6, cosine of pi over 6, sine of pi over 6, then cosine of pi over 3, and sine of pi over 3. So this is going to be sine of x times the cosine of pi over 6 is going to be square root of 3 over 2, plus the cosine of x. The sine of pi over 6 is 1/2, minus the cosine of x, the cosine of pi over 3, okay, I have to think about that, is going to be 1/2, plus the sine of x times the sine of pi over 3 is square root of 3 over 2. Alright, now, see what happens. Okay, by the way, all we did there was just evaluate. We used our unit circle to evaluate trig expressions. Now, cosine of x times 1/2 times the negative cosine of x times 1/2, those terms cancel. So I'm left with, and I like the number in front of my trig function, so let's say that's square root of 3 over 2 times sine of x. And there's another one down here, plus the square root of 3 over 2 times sine of x. Now, are we allowed to do that? Change that order? You bet, because that's the commutative property of multiplication. Okay, so you can rearrange multiplication, the order all day long if you want to. So what did we do here? We added like terms. And if you really want to write it down, we use the commutative property of multiplication. Now, we're going to add like terms again, too. We're going to add square root of 3 over 2 sine of x plus square root of 3 over 2 sine of x. There's 2 of those. So that's 2 square root of 3 over 2 sine of x's. Again, like terms. We could have done that in the line before, but I just want to make it clear. And since there's 2 of them, those 2's cancel. So you get square root of 3 sine of x, which is exactly what we were trying to prove. Notice I didn't even go to the other side. By the way, it's a cancel step here. I didn't even go to the other side to see what we were trying to get. I just started simplifying, and that's what we ended up with. All right, let's verify this identity. Notice we have a sum again inside a tangent. What you know right off the bat, that is not tangent of x plus tangent of 3 pi over 4. There's more to it than that. You have to use the sum difference formula. But I'm going to start with the left-hand side and rewrite what I have, tangent of x plus 3 pi over 4. And then the next step is to actually use the formula. So that's tangent of x plus the tangent of 3 pi over 4 over 1 minus the tangent of x times the tangent of 3 pi over 4. And again, that is just the sum difference formula. In particular, it's the sum formula for tangent. Now, it's time to evaluate, because we can evaluate the tangent of 3 pi over 4, okay? So the tangent of x, it just remains, plus, but the tangent of 3 pi over 4, now let's think about this for a second. First of all, where is 3 pi over 4? Remember, that's 1 pi over 4, 2 pi over 4, there's 3 pi over 4 right there. Okay, this angle right here. Now, the tangent is y over x. The y value is positive, square root of 2 over 2. The x value is negative, square root of 2 over 2. So basically, the tangent of 3 pi over 4 is negative 1. Okay, denominator, I have 1 minus the tangent of x, and if you want, you can go ahead and replace it with negative 1, which would have been fine right here as well. I just wanted you to see where that negative 1 came from. So the step there is just an evaluate step. We just determined what the tangent of 3 pi over 4 was. All right, now keep going. That's the tangent of x minus 1 over, okay. Now, down here, this negative, remember, this is not the tangent of negative 1. This is negative 1 times this negative. So that's 1 plus the tangent of x. Notice again, I really haven't even thought, or you might not realize that, but I didn't go back and take a look at the right-hand side. All I did was start the left-hand side, simplifying as much as I could, and I landed with the right-hand side without even giving it a thought. So these identities are not too bad. Okay, now what can I say I did here? Multiply, simplify, multiply. That's it. All right, done with that proof. All right, secant of alpha plus beta. They want us to show that secant of alpha, secant of beta over 1 minus tangent of alpha, tangent of beta. Okay, let's try. Now, I can tell you right off the bat that secant of alpha plus beta is not secant of alpha, secant of beta, right? And we don't have a formula for secant of alpha plus beta, okay? So the thing is, we're going to have to use a reciprocal in this problem immediately so we can use a formula we do have. And what is the reciprocal of secant? So here we go. Let's start left-hand side. Is secant of alpha plus beta. Now I'm going to rewrite that as 1 over the cosine of alpha plus beta. Again, why? Because I don't have a formula for secant of alpha plus beta. I have a formula for cosine of alpha plus beta. All right, so my explanation there is reciprocal. Now I'm going to use my formula. So that's 1 over, and the formula for cosine, remember, goes cosine, cosine, sine, sine, and the operation changes. So it's cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Okay, so again, we're just using the sum difference formulas to do that. Specifically, the sum formula for cosine. Now I need to look at the right-hand side and see what I have going on here. It looks like a huge jump from what we have right here to what we have right here. But it actually reminds me of the proof for tangent of alpha plus beta. I have my minus sign, notice that. If this term right here, cosine of alpha, cosine of beta, how do we turn that into a 1? Well, I think if we just divided it by cosine of alpha, cosine of beta, it would turn into a 1, right? So let's try something weird. Let's multiply the numerator and the denominator by 1 over the cosine of alpha, cosine of beta, which is essentially a unity fraction. So we have some unity fraction action going on, okay? And it'll end up having a cosine of alpha, cosine of beta under this cosine of alpha, cosine of beta here. Okay, so here I'm going to write down my unity fraction. I'm multiplying the numerator, which is 1 over the cosine of alpha, cosine of beta, okay, over 1 over the cosine of alpha, cosine of beta. That's my unity fraction that I am multiplying by my problem. 1 And then I'm recopying cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Okay? And again, this is just unity fraction stuff. Okay? Unity fraction action. Now, I distribute right here. Well, I say it's not distribute. I just multiply. There's not addition or subtraction up here. I will distribute down here. So in the numerator now of my big fraction, okay, is 1 over the cosine of alpha, cosine of beta. Now, I'm going to multiply this fraction times that, which is going to give me the cosine of alpha, cosine of beta, that's here, over the cosine of alpha, cosine of beta, here, okay? Then I'm multiplying this times the second term. So minus sine of alpha, sine of beta, over cosine of alpha, cosine of beta. Okay, so that's the distributive property I used, and I multiplied, okay, which is all the distributive property really is. Now I'm there. Believe it or not, I'm there. 1 over the cosine of alpha is secant of alpha. 1 over the cosine of beta is the secant of beta, divided by, okay, cosine of alpha over cosine of alpha is 1, and cosine of beta over cosine of beta is 1. Again, that's how I came up with this trick in the first place, because I knew that needed to turn into a 1. And then sine of alpha over cosine of alpha, it's hard to see right here. Sine of alpha over cosine of alpha is tangent of alpha, so minus tangent of alpha. And then sine of beta over cosine of beta is tangent of beta. And we used the reciprocal property, and we used the quotient property to get to the end. All right, let's verify another identity. I've got cosine of alpha minus beta, okay, over cosine of alpha, cosine of beta, and they're telling us that's 1 plus tangent alpha, tangent of beta. So I'm going to start with the left-hand side. I'm going to write it, and then the next step, I'm going to use the difference formula for cosine. Okay, so the difference formula for cosine is, remember, cosine does not alternate. It goes cosine, cosine. The operation changes, and then sine of the first angle, which is alpha, and sine of the second angle, which is beta, divided by cosine of alpha, cosine of beta. Okay. All I did was use the sum difference formula. In particular, it's the difference formula for cosine. Now, we're there, folks. We're there. This is so much easier than the last proof we did. I can put cosine of alpha, cosine of beta underneath each one of these terms separately. So I have cosine of alpha, cosine of beta, over cosine of alpha, cosine of beta, plus sine of alpha, sine of beta, over cosine of alpha, cosine of beta. Okay, and all I did was split my fraction up. Alright, now how did that help us here? Those cancel, and that gives me 1. Here, I've got sine of alpha over cosine of alpha, that is tangent of alpha, and I've got sine of beta over cosine of beta, so that's tangent of beta, and so I canceled to get the 1, and I used the quotient identity twice to get the tangent of alpha, tangent of beta, and that's the end of our proof. Okay, folks, let's keep going. We got cosine to the 4th of x minus sine to the 4th of x, and that's telling us that's the cosine of 2x. Now, first of all, notice I have just regular old x over here on the left, and I have 2x on the right. So somewhere, somehow, we're going to have to use a double angle formula to work on this. I still think the left-hand side is more complicated than the right-hand side, even though that's screaming double angle formula over here. I don't want to do that yet. If we have to meet and go backwards to meet in the middle somewhere, we can, but maybe we won't have to do that. Left-hand side, cosine to the 4th of x minus sine to the 4th of x. Okay, Well, to me, that's screaming, factor me, please factor me, because it's a difference of squares. So again, try something as the rule. So here we go. We've got to factor a difference of squares. Remember, factors into one plus factor and one minus factor. And then the first spot on both of these is the square root of the first term. So the square root of cosine to the fourth of x is cosine squared of x. And the square root of sine to the fourth of x is sine squared of x. Okay, so we just factored. In particular, we factored using the difference of squares technique. Okay, aha! What about this dude right here? Cosine squared of x plus sine squared of x, that's just 1, right? So I have 1 times the cosine squared of x minus the sine squared of x, and we're using Pythagorean right there. And that is just the double angle formula. When I multiply 1 times that, if you look up your double angle formula, that's it. Cosine squared of x minus sine squared of x is cosine of 2x. And that's double angle. Okay, not bad. All right, let's verify another identity. Let's start with the left-hand side. I can't say really, honest to goodness, that the left-hand side is any less or more complicated than the right-hand side. I do know I'm going to have to use the double angle formula because look, there's just only an x here, only an x here, only an x here. Something happened to that. So we need a double angle formula. Here's the hard part. Cosine has 3 different formulas listed for the double angle formula. 3 of them. So we've got to figure out which of those 3 is appropriate. Now when you're doing calculations, I've told you that any of the 3 will work if you have the needed information. Well, in this case, any of the 3 of them won't work, or if you use one, you'll end up having to use a different substitution to get to the next one. But here's how I'm going to decide which one to use. Notice my right-hand side has nothing but sine in it. There's no cosine. So when I substitute for cosine of 2x, I want to use the double angle formula that has only sines in it. Okay? So you might need to go look that up. That's what I'm going to do. It's going to be the next line. This sine of x stays, minus, and I'm going to look up the double angle formula for cosine of 2x that has only sine values in it. And that's going to be 1 minus 2 sine squared of x. Okay? Now, parentheses that I've got there are required because this minus is going to have to distribute inside. And I need to also write what I used, and I used a double angle formula. And I was required because I had to get rid of this 2x because there's not a 2x in any of my other terms or pieces of the expression for my problem. Now I'm going to distribute. So I got sine of x minus 1 plus 2 sine squared of x. So that's the distributive property. All right. Now, what's bothering me about this, notice what we've got compared to where we're going. This appears to be factored. Okay, and this is not, clearly. You may want to rearrange this into descending powers order. So put the sine squared first, which is 2 sine squared of x. Put the sine term next, plus sine of x, and then minus 1. Okay, can you do that? Sure you can. That's the commutative property of addition. Now the next thing I'm going to do is factor. Okay, but now how do I know what it factors into? Don't look at your final answer and just hope that's right. You need to be confident that you're factoring this correctly. So what this is like, this is a trinomial. You're not used to seeing them with trig functions in there. So think about this as 2, and this is just x squared. And then this is just plus x, and this guy is just minus 1. So you got to think about how that factors, okay? The only way to get the 2x squared is a 2x and an x, okay? The only way to get the minus 1 is a plus 1 and a minus 1. Question is, does the plus 1 go here, or does the plus 1 go here? It turns out the plus 1 goes here, because when you multiply 2x times that 1, is going to give you a positive 2x, and that's going to give you a negative x, and it's going to have to add to be a plus 1. So this is our story, but everywhere x is in our story up here, a sine of x goes down here. So this is equivalent to 2 sine of x minus 1 times sine of x plus 1. And that's just factoring a trinomial, and that's exactly what we have on the right-hand side. All right, let's verify another identity. So the left-hand side, and I think to save a little bit of space, folks, I'm not going to rewrite the left-hand side. Okay, I know I should, but space is at a premium on this little bitty board. All right, sine of 2 theta minus sine of theta. So I have a 2 theta here. I have just a theta here. My final answer is just in terms of theta. That's saying use the double angle formula. So the double angle formula for sine of 2 theta, you may have to look it up, is 2 sine of theta cosine of theta. Okay, there's not another option for that. That is the only answer, minus the sine of theta. Okay, and we're using double angle. But now when it gets to the denominator, okay, this cosine of 2 theta right here that I have to replace, I've got 3 different formulas for cosine of 2 theta. And the question is, what do I want to use? Now my thought, I don't know, my thought is, notice how it's already got a plus cosine of theta right here? Maybe let's stick to just cosines. Or maybe that'll work. Let's just stick to just cosines, because that would give us cosines for everything. If we need to change it after that, we can. But the formula for that is 2 cosine squared of theta minus 1. And then that's plus cosine of theta. Alright, so we use the double angle in both the numerator and the denominator. Okay, next. What do you think we should do next? I do see that in the numerator there's a greatest common factor, because you've got this term, 2 sine of theta times cosine of theta, and this term, sine of theta. We could factor out a sine of theta. In the denominator, we might want to write that in descending order and see if it'll factor. So here I go. In the numerator, I'm going to factor out a sine of theta. This is in the realm of try something. That's going to give me 2 cosine of theta minus 1. Right now, I don't know if that's the right thing to do or not, but that's what we've got. Okay. In the denominator, again, I want to try to factor it, but maybe if I write it in the right order, 2 cosine squared of theta plus the cosine of theta minus 1. So in the numerator, I factored the greatest common factor. I'm just going to put GCF. And in the denominator, I use the commutative property of addition. I'm just going to put commutative property in hopes of this factoring. So I have sine of theta times 2 cosine of theta minus 1 in the numerator over, let's just play around, see if it'll factor. Now, I know that my first term, I need a 2 cosine of theta, and I need a cosine of theta. That's going to multiply back to give me 2 cosine squared of theta. The last term, I need a 1 and a negative 1. I've just got to figure out which one is going to be the positive and which is the negative. The positive one is going to be this one, because when I multiply 2 cosine of theta times 1, it's going to give me 2 cosine of theta, and that one's going to be a minus cosine of theta, which would add to be a positive 1. Alright, so factor. Specifically, I factored a trinomial. But if you just put factor, I'm happy with that. Now I see something good. Okay, I see the 2 cosine of theta minus 1s, those cancel. So now I've got sine of theta in the numerator and cosine of theta plus 1 in the denominator. So what did I do? I canceled. But that doesn't look like what I've got. It looks far from like what I've got. But if you'll remember a technique from before, if you're at a place and you're stuck, you don't have any squares going on, You can multiply by the conjugate, especially if it appears on the other side of where you're going. So I'm going to multiply this thing by the conjugate of cosine of theta plus 1. And that would be the cosine of theta minus 1 on top, cosine of theta minus 1 in the denominator, times this sine of theta over cosine of theta plus 1. This also tells me there's probably a better way to do this problem, and I didn't do it. It could have been even as simple as substituting something different here, but I just don't see it without, writing it down and working through it. But we'll get there from here. I feel certain we'll get there. All right, so in the numerator, I'm going to leave that factored just in case, and if we have to multiply it back out later, we will. Okay, I feel like, see, that's 1 minus cosine of theta, and we have cosine of theta minus 1. That sine is going to end up canceling out somehow. All right, so I'm going to say that's sine of theta times cosine of theta minus 1. Again, I'm rearranging the order because it looks better. Over, in the denominator, now I do have to multiply that out because that's the whole point of multiplying by a conjugate. So that's cosine squared of theta plus cosine of theta minus the cosine of theta and then minus 1. Okay, so what I did here was just, this was unity fraction. And you could also call it conjugate. Okay, this was just distribute. And we only distributed in the denominator. We decided not to in the numerator. Now, I'm going to change colors so it doesn't run into what we've got going on over there. These middle terms cancel. So I have sine of theta times cosine of theta minus 1 over, okay, so the middle terms cancel. I have cosine squared of theta minus 1. Now the goal is, every time you use the conjugate, the goal is to use the Pythagorean identity. Now that's almost Pythagorean, but it's the opposite. You remember 1 minus the cosine squared of theta is sine squared of theta. So if we reverse that, that's going to give me negative sine squared of theta. You see what I mean? So sine of theta times cosine of theta minus 1. Let me write it in more detail for you. By the way, I didn't put a description here. Oh, Pythagorean. Okay, that's what that is, Pythagorean. Now, isn't it? No, I'm sorry, not yet. Getting out of control here. Hold on just a second. That was not Pythagorean. All we did there was add like terms. The Pythagorean is happening as we speak. So right here, okay, watch this. I'm going to factor a negative out of there. Okay, that'll make that negative cosine squared of theta plus 1, which is the same as 1 minus cosine squared of theta. So this part is sine squared. Okay, so now I have, and all that is just a factor step. So now I have sine of theta times cosine of theta minus 1 over, this negative is still there, and this part is sine squared of theta. And again, that's a Pythagorean step right there. This sine cancels with this sine. So that leaves me, the negative I could take to the top too. Make it negative cosine of theta minus 1 over sine of theta. And again, that's a cancel step, cancel common factors. And then finally, we're there, because if I distribute this negative inside, that's going to make that negative cosine of theta plus 1 over sine of theta. That's a distribute step. And then I can rearrange the order by saying this is 1 minus the cosine of theta over the sine of theta, and that is a commutative property again. And whew, I just barely squeezed it in. Okay, I know that one was a doozy.